What do we do with that 1/2? That 1/2 looks frightening to me. Chris, since you're waving your hand up, go for it.
So since you want everything to be log 3, you want to put the 1/2 as an exponent in the 56.
Excellent. And then I'm going to let you guys finish it.
You guys got 54 as well.
If you ever see this question in your life, whether it's on a test or in university, they all have to be in terms of log. So what we did is we just did the opposite of the step that we did. So instead of bringing the log, the 1/2 down like we normally do, we just brought it up. How does that help me? What's 36 to the 1/2? 6. So this is going to be log 3 to the x. Yeah. Good. Without that step, though, that was a little trick by me. Okay, without that step, this one's impossible to do. Okay, I'm a teacher, I'm allowed to throw a little bit of brain here, so that's my job. Okay, Callan, since I'm sort of stopped doing Spider-Man, I'm going to pick on you because I always pick on you. What's my power rule for log 3/6 plus log 3/18 minus log 3/2?
It would be log 3/6 times 18.
Okay. Okay, good. Can we do all 3 of those together? What is the minus 3 log 2? What does that turn into?
Would you do like close to the same time?
Yeah, you can do it all together.
Wow.
Okay, which will give you the same answer, right? So that's, yeah.
Would you mind if I took the log 3 to do over to the other side and have it, because that's what I did and I still end up with the same answer.
Oh, I'll try that in a sec, because I like that creativity. I'm going to do it this way first, but then I like that, okay? So this turns into log 3 to the x equals log 3. I can't do this in my head. 54, I think it is. Somebody help me?
Yeah, 54.
Yeah.
So x equals 54. Now, if that 1/2 is going to mess up the numbers, right? So once you got that 1/2 taken care of, you should have no issue. I'm going to just experiment here with, so you did this as log 3. Yeah, this will work the very same way, right? So you'll get 2x equals, I went away, thank you. I like that too. Both those are great ways to do it.
Okay.
Yeah?
Yeah.
Yeah. All right. Can I continue now? All right. Let's start solving things with quadratics in it. What example now? 7?
Yeah.
Do you guys know in my 9 applied class yesterday, we're getting ready for our EQAO, and I labeled, started at letter A, and got all the way to Q, which was awesome. And I told him I wanted to get to Z, and we couldn't do it, so maybe today. I'm going to hit pause in the video and let you guys try this for yourself. I'm going to pause the video and give you guys a minute to try this one out. Then we'll do one more, and then I'll talk about a new number similar to pi, but different. Okay. Okay, so here we go. Luke, I'm going to pick on you. What do we do with the left-hand side?
You go log 6.
Yeah.
Bracket x. Bracket x plus 1.
Good.
Bracket.
Great. That looks wonderful. Now, someone other than Luke, what do you do with that 1 on the right-hand side? Bailey, go ahead. Good. So log 6. I'm going to write that. I just write that as x squared plus x. Okay, now Bailey instantly raised her hand to know that one. Can someone other than Bailey explain me why we needed to change 1 to log 6/6? Chris, go ahead.
So then we can match it, so we can take down the 1/6 in general.
Right on. So whenever you don't know what to do in these questions, you have to think to yourself, I want to get rid of all the logs because it's more difficult to calculate stuff, right? The only way to deal with that one is to change to something with log base 6. All right? So now we're going to drop the bases or drop the logs, okay? So it's going to be x squared plus x equals 6. And you guys are calculoid, so I don't need to tell you guys this. And you're wonderful math students. But someone in this class is going to try and divide by x here. Don't do it. Noah Solinger. How do we solve for x here? What's the first step? Uh-oh. No, who taught you grade 9, 10, and 11? That person's, shame on that person. How do we solve for x here? Nathan Cannon.
Bring 6 over.
Thank you. Jeez, did you just say quadratic formula for this one? Please don't. Sorry, I don't need, I'm sorry, I mean, that good mood which means I'm insulting students, I'm sorry. Now, it says log 6 of x. Can you take the log of a negative number?
No.
No, you cannot, so this one's gone. So our only answer is going to be x equals 2. Okay. Now, algebra like this you will have to do in this unit, so I want to make sure we're feeling sort of good about this. Something like this one's okay. I'm going to do one more, then I'm moving on to E. Chris? Yes? Okay. Oh, let's pick the hardest one I can think of. Example 8. Okay, do you guys want to try this? You say, sure, I'm giving you 1 minute to try it. When I say 1 minute, I mean 90 seconds. That's log the cube root of x squared plus 48x equals 2/3. Now, do not be afraid of trying, so I'm going to take this one up here. So, as I just said to Callan here, I'm going to instantly switch this into log x squared plus 48x. To the 1/3 equals 2/3. Okay, now there's 2 magical steps after this question which make this a hard question. What's the first magical step going to be? Go ahead, Haley. Bring the 1/3 down, because there's nothing I can see that you do. So I'm going to call that 1/3 log of x squared plus 48x equals 2/3. Okay, now for the real magic step. And Chris is just jumping out of his chair. Yes. You know, I'm gonna miss you next year, Chris. All joking aside about how much you raise your hand, I'm really gonna miss you. You helped me a great deal in grade 9 when you raised your hand so much, and helped me again this year. Go ahead, Chris.
Okay, so you can multiply by 3 to get rid of the fractions.
Good. Okay. Now, can I get another volunteer? Because we're getting close here. Sorry, Chris, you're out. Derek, what do we do now?
On the right hand side, we can make the 2 of log and do the 2.
Thank you. All right, so things are looking good to me. What do I do next, if anything? Drop the log. So I'm going to call this then x squared plus 48x equals 10 squared, which is x squared plus 48x minus 100 equals 0. Now, I'm going to pick on Nathan. Nathan, because I'm confident in your abilities here. Nathan is going to yell quadratic formula at me. I'm going to say shame on you, Nathan. What multiplies to negative 100 and adds to 48? We'll think of some easy ways to multiply to 100. 50 and negative 2. And again, all kidding about the quadratic formula. You can use the quadratic formula. This is just a lot faster. That's why I'm doing it this way. Okay, so your homework tonight is going to be just on this. It's going to be page 250. Now, what I'm going to hope for you guys tonight is this. If you're feeling good about this, they don't pack up yet, Emma, because we're still, oh, sorry, that's, no, okay. Because I still got more to do. I want to try and squish as much as I can into today's lesson, if possible. Okay, so I'm going to talk with the letter E and just do the foundational stuff. Here we go. Are you ready? Yeah.
For example 8,
Yes.
would you be mad if I didn't do it exactly the way you did?
As long as you get a quadratic that's 50 and 2, that's fine. I know I wouldn't be mad as long as you like the nice. And this is what I always tell kids about algebra is imagine like you're skiing down a hill.
Yeah.
I try and take you down the bunny hill. If you want to go down the black diamond approach to solving a question, go ahead.
It was
As
just
long
as easy as like,
Okay.
I did the 10 over first and then I cubed them both.
Oh, okay. Oh, okay, yeah. Yeah, that works the same thing, right? Also right here, it'd be 4 over, or whatever, 8 over 27. All right, here we go, the letter E. What's the number E? Okay, E is a magical number. Going back to my favorite subject, which is compound interest. That is in fact the pain formula. You don't think compound interest is my favorite subject? Okay, well in grade 11 I spent like, do you guys want the lesson of how to be a millionaire? I'd love to teach that.
I really liked that. That really helps.
If we have enough time, I'll do it. But again though, you hated that? Okay.
Do you want to be a millionaire, either work hard or win the lottery?
They are all the same, that's true. But anyway, this is the pain formula, that's what this is. 1 plus I to the n. This is in fact infinite compounding. Okay, so if you remember what you would do is you divide your interest by the number of periods and you'd multiply by the time, right? So this is the pain formula. Where if you send the limit to infinity, which means infinite compounding, so you compound once every infinitieth of a second, okay, on something, it's going to be 2.718. Okay, that's what it's going to be. So that's the number for E. There will be an E button on your calculator. The reason that E is important to us, and I don't really have time for this, but I'll do a little bit here. We're going to say, just as the inverse of 10 to the x is log 10 to the x, the inverse of e to the x is log e to the x. We call this the natural logarithm. Okay, so ln on your calculator, and if some of you guys did I can't remember if I do ln or log depending on the year. ln just means log base e is what it means. Okay, it's ln. One last trick for you guys, and what I normally do is that I get you guys to calculate this out and do a little bit of a discovery, but I'm not really in the mood for that today. But the magical part of e to the x, there's so many magical things about e to the x. Okay, it's non-terminating and non-repeating. So Chris, that means it's just like pi. There's no pattern to it. It goes on infinitely and there's no patterns to it. And this is the other thing that's amazing about it. If f of x is equal to e to the x, f prime of x is also equal to e to the x. Okay, which is unbelievable when you think about it. Okay, right? It's the only function that's rate of change is the same as its function. If you take 2 to the x, it's not going to be the same rate of change as 2. Okay, right? If you do 3 to the x, it's not going to be, but e to the x, the derivative is still e to the x, which is a little bit wild if you think about it. Okay? We'll talk more about those derivatives in the next few days, okay? But I'm going to stop there for today. We've done a lot with logarithms, okay? So, but those are the 2 things you should know about as far as this here. That's the key part about this and where it comes from. If you do 1 plus 1 over 10,000 to the power of that 10,000, should a number derivative close to 2.718 ... Okay?
So,
I guess technically would be also times the derivative. We'll get into what we get to change. We won't times the derivative of this formula would be 0. Okay, but the basic function of the is just the same thing, which is cool.
what's that, is that e-text one, or is that not?
How much time do I have?
5 minutes plus.
Oh, that's 0 minutes. We have 0 minutes left in the class. The bell's about to ring. Ding.